Hi to everyone, I am Dr VNSR Venkateswara Rao, working as an Associate Professor from the Department of Chemistry in the Institute of Aeronautical Engineering, Hyderabad. So today I would like to give one of the important topic, nothing but problems on the electrode potential of the half cell by using Nernst equation. So first of all, we see what is the importance of the Nernst equation. So before starting this topic, first we see what are the contents involved in today's section. So first we see introduction to the electrode potential of the half cell by using Nernst equation. After that, we continue problems. Okay. So first of all, we see the equation. The Nernst equation enables the determination of a cell potential under non-standard conditions. Generally, what is the standard conditions? Nothing but the cell potential is maintained at 1 molar concentration and 1 atmospheric pressure and 273 Kelvin temperature. So from the cell potential, the Nernst equation is given by E is equal to E naught minus 0.0591 by N log of 1 by Mn plus. So that means where E represents the cell potential and E naught represents the standard electrode potential or electrode potential, and small n represents the number of electrons involved either in oxidation or reduction reactions. Okay, next where Mn plus represents the concentration of metal ion Okay, so this is the terminology present in the equation where A represents the electrode potential and E naught represents the standard electrode potential and N represents the number of electrons involved in either oxidation or reduction. Oxidation means loss of the electrons takes place and reduction means gain of the electrons takes place. And Mn plus is represents the concentration of the metal ion present in the aqueous solution. Now let us see the problems. Calculate the electrode potential of the copper wire dipped in 0.1 molar copper sulfate solution at 25 degrees centigrade. That means room temperature. The standard electrode potential of the copper wire is given 0.34 volts. That means given data is equal to standard electrode potential, that is nothing but E naught is equal to 0.34 volts. Okay, now the formula is E is equal to E naught minus 0.0591 by N log of 1 by Mn plus. That means E is equal to E naught minus 0.0591 by N log of concentration of Mn plus in aqueous media. Okay, so this is the formula. Now substitute the values. 0.34 volts minus 0.0591 by N. N is equal to how many? 2 electrons. And log of concentration of Mn plus. What is the concentration given? 0.1. So E is equal to E naught minus 0.0591 by N log of 1 by Mn plus, and E naught is given as per given data 0.34 volts and 0.0591 by N. N means number of electrons. In the copper, how many electrons involved in the reaction? That means it is the characteristic potential of a reduction reaction. That means copper plus 2 by the gaining of 2 electrons to get copper. So that means reduction reaction takes place. That's why how many electrons involved? 2 electrons. So since N is equal to 2. Okay, and concentration of metal ion given in the sum, that is 0.1 molar copper sulfate solution. Okay, now calculate this equation. 0.34 minus 0.03. Finally, we get 0.31 volts. Okay, so this is the cell potential of a given reaction. So that means they ask the electrode potential, and that electrode potential should be equal to 0.31 volts. Okay, now let us see next problem. Calculate the electrode potential of zinc rod dipped in 0.1 molar zinc sulfate solution at 25 degrees centigrade. The standard reduction electrode potential of the zinc is equal to minus 0.76 volts. That means given data, E0 standard electrode potential should be equal to minus 0.76 volts. Okay, and the formula is E is equal to E0 minus 0.0591 by N log of concentration of Mn plus in aqueous media. Okay, so that means we got E0 is equal to minus 0.76 volts and minus 0.0591 by N. N means 2. Log of concentration of metal ion given 0.1. That means 1 by 0.1. Why? Because in the as per the standard electrode potential, zinc undergoes the oxidation reaction. That means zinc undergoes zinc plus 2 electrons. That means how many electrons are in the reaction? 2 electrons when zinc undergoes the oxidation reaction. That means since N is equal to 2. Okay, now substitute this equation, minus 0.76 volts minus 0.03, and finally cell potential we got minus 0.79 volts. Okay, so finally we got the value of the E. That means cell potential should be equal to minus 0.79 volts. So they ask the electrode potential, and finally we got the electrode potential should be equal to minus 0.79 volts. So this is the solution for the model problem 2. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.